Hello dear students, in our last video we have solved some multiple choice questions from kinematics related to the displacement and distance. In this video we are going to solve some multiple choice questions from kinematics with uniform motion. At first let us review the related formulas and tips. This is the velocity time graph. Particle moves with initial velocity u from point A to B, where velocity becomes v. Here the velocity is v. Then the slope of this curve, here slope of this straight line gives the uniform acceleration A is equal to velocity change upon time. From this we get final velocity v is equal to u plus at. Area enclosed by this curve with time axis gives the total displacement, which is s is equal to ut plus half at square. And from these two relations we can find b square is equal to u square plus 2as. Displacement in nth second is given by the formula Sn is equal to u plus a by 2 into 2n minus 1. Notes: first, for retardation we replace plus with minus in these equations. We replace plus with minus in equations 2, 3 and 4. Second, for vertical motion a is replaced by plus g for downward motion and a is replaced with minus g for upward motion, and s is replaced by h height in equations 2, 3 and 4. Next, in the displacement time graph shown in this diagram, if a particle moves with velocity v1 at slope at angle theta 1 and other particle moves with velocity v2 at angle theta 2 with time axis, then tan theta 1 upon tan theta 2 gives the ratio v1 upon v2. Next, instantaneous velocity v vector is equal to rate of change of displacement dr vector upon dt, which is limit delta t tending to 0 delta r vector upon delta t, which may be written as dr vector upon dt in terms of derivative. Next, average speed is given by total displacement upon total time, total distance upon total time. First, if first half of displacement is troubled with velocity v1 and second half of displacement is troubled with velocity v2, then average velocity will be v average is equal to d1 plus d2 upon t1 plus t2. Because both half displacements are equal, suppose equal to d, then d plus d upon t1 is equal to d upon v1 and t2 is equal to d upon v2, which gives 2 b1 b2 upon v1 plus v2. Third part, if a particle moves equal distances d1, d2, d3 is equal to d with velocities v1, v2 and v3 respectively, then average velocity will be equal to d1 plus d2 plus d3 upon t1 plus t2 plus t3, which finally gives V average is equal to 3 V1 V2 V3 upon V1 V2 plus V2 V3 plus V1 V3. Next, if speed is V1 for time t1 and V2 for time t2, then average velocity V average equal to d1 is equal to V average is equal to d1 plus d2 upon t1 plus t2, which gives V1 t1 plus V2 t2 upon t1 plus t2. Now question number 1. The question is the displacement time graph for two particles A and B are straight lines inclined at angles of 30 degree and 60 degree with time axis. The ratio of velocities of VA to VB is, we have to find the ratio of velocities VA and VB. Now solution to question 1. We know B1 upon B2 is equal to tan theta 1 upon tan theta 2. This will be tan 30 upon tan 60. Tan 30 is 1 upon root 3 and tan 60 is root 3. So the required ratio will be 1:3. So the correct option will be A. Next question number 2. The question is a car travels half distance with constant velocity 60 km per hour and the remaining half with constant velocity 60 km per hour. The average velocity of the car in km per hour will be. Now solution to question 2. Here first half and second half distances are equal, therefore V average will be equal to 2 V1 V2 upon V1 plus V2, because D1 is equal to D2. So 2 into 40 into 60 upon 40 plus 60, which gives 2 into 40 into 60 upon 100, which finally gives 48. So the correct option will be B, 48 km per hour. Next question number 3. The question is a particle moves along a semicircle of radius 10 meter in 5 seconds. The average velocity of the particle will be. Now solution to question 3. Here suppose this is circle of radius 10 meter. Particle moves from point A to point B. From point A to point B. So we have to find the average velocity. This is 2r is equal to 2 into 10 means 20 meter. So V average will be equal to, average velocity will be equal to displacement upon time taken. Displacement is AB vector upon T. AB vector is 20 meter and time is 5 seconds. So the average velocity will be 4 meter per second. So the correct option will be B. Next question number 4. The question is a 150 meter long train is moving with uniform velocity 45 km per hour. time taken by the train to cross a bridge of length 850 meter is. These are the options. Now solution to question 4. Here suppose this is bridge. Its length is 850 meter and this is train. (150 meter). Then when the train crosses the bridge, total distance moved by the train will be d will be equal to d1 plus d2, that is 150 plus 850 means 1000 meter. Therefore, time will be equal to distance upon velocity, where velocity is 45 kilometer means 1000 meter upon hour means 3600 second, which gives 25 upon 2 meter per second. So d is 1000 meter and this is 25 upon 2 means this. So the time taken will be 80 seconds. In this time, this train will cross the bridge reaching here. So total distance travelled by the train will be d1 plus d2 and car will reach and the train will reach here. Now question number 5 is, a train has a speed of 60 km per hour for the first hour and 40 km per hour for the next half hour. The average speed in km per hour will be. These are the options. Now solution to question 5. V average will be equal to d1 plus d2 upon t1 plus t2. d1 will be equal to b1 t1 and d2 will be equal to b2 t2. So this is equal to b1 t1 plus b2 t2 upon t1 plus t2. Putting the values we get b1 is 60, t1 is 1, b2 is 40, t1 is 1 by 2 and t1 plus t2 means 1 plus 1 by 2 means 3 by 2. So we get 80 into 2 upon 3, which will give 53.33 kilometer per hour. Therefore, the correct option will be D. Next question number 6. A bullet emerges from the barrel of length 1.2 meter with the speed of 640 meter per second. Assuming constant acceleration, the approximate time that the bullet spent in the barrel after gun is fired is. These are the options. This is the length of barrel, which is equal to 1.2 meters. Initially U is 0 and finally V is 640 meter per second. We have to find the time spent by the bullet in the barrel. So B square will be equal to U square plus 2A S. This is equal to S. This is 0 plus 2A into S. B square. A will be equal to B square upon 2S. B is 640. Its square upon 2. S is 1.2, which gives 204800 meter per second square. Therefore, B is equal to U plus 80, 0 plus 80, which gives T as B upon A. B is 640 and A is 204800. This gives 3.75 into 10 to minus 3 second. So the correct option will be 4 millisecond. That is option number B. Next question number 7. The question is, a car moving on a straight road covers 1/3 distance with velocity 20 km per hour and rest with velocity 60 km per hour. The average speed in kilometer per hour is. These are the options. Is now solution to question 7. B average will be equal to d1 plus d2 upon t1 plus t2, d1 plus d2 upon t1 plus t2. d1 plus d2 is total distance d, and t1 can be written as d1 upon b1 and t2 can be written as d2 upon b2. This is d upon d1 is 1/3 d upon this b1 plus d2 is 2/3 d upon this b2. So we get d upon d by 3 can be taken common, 1 by b1 plus 2 by b2. dd cancels out and 3 goes to denominator. This will be 3 upon 3 goes to the numerator, so we get 3 upon 1 upon 20 plus 2 and 2 1 upon 60. It is 3 upon 60 is LCM. 3 plus 2, so it is 3 into 60 upon 5, that is 36. So the correct option will be C. Next question number 8. The question is, a car covers 2/5 of the total distance with the speed v1 and rest with speed v2. The average speed is. These are the options. So solution to question 8. B average will be equal to d1 plus d2 upon t1 plus t2. d1 plus d2 is total distance d, and t1 can be written as d1 upon b1, t2 can be written as d2 upon b2. So this is d upon d1 is 2 by 5 d upon this b1 plus remaining is 3 by 5 d upon b2. This is d upon 5 can be taken common in the denominator, so we get 2 upon b1 plus 3 upon b2. dd cancels out and we get 5 goes to the numerator. This is 2 b2 plus 3 b1 upon b1 b2, so b1 b2 goes to the numerator, so the correct option will be 5 b1 into b2 upon 2 b2 plus 3 b1, so the correct option will be D. Next question number 9. The question is, a man walks on a straight road from his home to the market 2.5 km away with a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back with the speed 7.5 km per hour. The average speed of the man over the interval 0 to 40 minutes is. These are the options. So, solution to question 9. Here suppose this is home and this is market. Market is M, home is denoted by H. Total distance D1 is 2.5 km. From home to market, velocity is v1, therefore time t1 will be equal to d1 upon b1. d1 is 2.5 km and b1 is 5 km per hour, kilometer per hour. So t1 is 0.5 hour, which will be 30 minutes. Now the remaining time is 40 minutes minus 30 minutes means 10 minutes. In 10 minutes during returning, suppose the person comes from point M to point P, covering distance d2. In time t2 is equal to 10 minutes. d2 will be equal to b2 into t2. b2 is 7.5 km per hour into t2 is 10 minutes. So it can be written as 7.5 km per hour. Hour can be replaced by 60 minutes into 10 minutes. Minute gets cancelled and we get 7.5 upon 6, which gives 1.25 km. Therefore, V average will be equal to d1 plus d2 upon t1 plus t2. d1 is 2.5, d2 is 1.25, t1 is t1 plus t2 is 40 minutes converted into hour, 40 upon 60 hours. This can be written as 3.75 kilometer into 60 upon 40 hour, which gives 12 upon 8, which is 45 upon 8 kilometer per hour. So the correct option is D. Next question number 10. The question is, two boys are standing at ends A and B of a ground where AB is equal to small a. The boy B starts running in a direction perpendicular to AB with velocity v1, and the boy B at A starts running simultaneously with velocity v and catches the other boy in time t. The value of t is here. Solution to question 10. Suppose this is point A and this is point B. Boy at B runs with velocity v1 perpendicular to AB. AB is equal to A, and at the same instant boy at A starts running to catch the second boy and catches second boy, suppose at point C. With velocity v. Because time taken by two boys to reach at point C is same, therefore from Pythagoras theorem, AC square will be equal to AB square plus BC square. AC is equal to velocity into time, so V into T square is equal to AB is A square and BC is velocity into time, B1 into T whole square. Because distance is equal to velocity into time, so it can be written as B square T square minus B1 square T square taken common, B square minus B1 square is equal to A square, which gives T as A upon under root B square minus B1 square. Therefore, we get T is equal to A upon B square minus B1 square. So, the correct option will be B. Next question number 11. The question is, a particle moves for 20 seconds with velocity 3 meter per second, then with velocity 4 meter per second for another 20 seconds, and finally moves with velocity 5 meter per second for 20 seconds. The average velocity of the particle is. Now, solution to question 11. Here B average will be equal to d1 plus d2 plus d3 upon t1 plus t2 plus t3. d1 can be written as here, because t1 is equal to t2 is equal to t3 is equal to t, suppose is equal to 20 seconds. So, this can be written as V1 into T1 plus V2 into T2 plus V3 into T3, because T1 is equal to T2 is equal to T3 is equal to T. So T plus T plus T means 3T. T gets cancelled out and we get V1 plus V2 plus V3 upon 3, that is 3 plus 4 plus 5 upon 3, which is 4 meter per second. So the correct option will be A. Next question number 12. The question is, a bullet fired into a fixed target loses half of its velocity after penetrating 3 centimeters. How much further it will penetrate before coming to rest, assuming that it faces constant resistance to the motion? So, solution to question 12. Here, suppose this is target. From point A to point B, initial velocity was u, and at point B its velocity v1 becomes u by 2. Suppose this distance is s1, which is given to be 3 centimeters. Then we have to find the further distance s2 such that the bullet comes to rest at point C. Now from point A to point B, B1 square will be equal to u square minus 2a s1. B1 is u by 2, so it is u by 2 whole square is equal to u square minus 2a into s1 is 3 centimeter. So we get u square by 4 is equal to u square minus 6a. Therefore, u square minus 1 by 4 u square will be equal to 6a, that is 3 by 4 u square is equal to 6a, which gives a as u square by 8. Now from point B to point C, this is final velocity and this one is initial velocity. Now from B to C, B square will be equal to B1 square minus 2a s2. This B is 0, B1 is u by 2 whole square minus 2a is u square by 8 into s2. This gives u square by 4 u by 2 whole square is equal to u square by 4 s2, which gives s2 as 1 cm. Therefore, the correct option will be A. Next question number 13 is, a bus begins to move with an acceleration of 1 meter per second square. A man who is 48 meters behind the bus starts running at 10 meters per second to catch the bus. The man will be able to catch the bus after, these are the options. Suppose A is initial position of man and B is initial position of bus. When the bus starts, at the same time the man starts running towards the bus to catch the bus. If at point C the man catches the bus, then time taken by man to reach from A to C will be equal to the time taken by bus to reach from B to C. Therefore, if time taken by man to reach from A to C is t second, then total distance S2 will be equal to u1 into t, because velocity u1 is constant. So S2 will be equal to 10 into t. Again S2 is 48 plus S1, 48 plus S1 will be equal to 10t. Suppose this is equation 1. Also, for the bus from B to C, S1 will be equal to ut plus half at square, u is 0 plus half a is equal to 1 into t square, that is t square by 2. So, equation 1 gives 48 plus t square by 2 is equal to 10t, which gives t square minus 20t plus 96 is equal to 0, or t minus 8 into t minus 12 is equal to 0. Therefore, t will be 8 seconds, or t is equal to 12 seconds. Thus, the man will catch the bus after t is equal to 8 seconds. That is, the correct option will be C.